Welcome back to this channel with practice problems for actuarial exams. As you know, I use this redirect service for websites, smarturl.it, and then if you after / you put a word that identifies a website, you get redirected to the websites that tell you about things that I'm mentioning here. So if you would like to find the actuarial program at Illinois State University, you could find it at smarturl.it /actuary. If you would like to give a tax-deductible donation to support our actuarial students, you can go to smarturl.it /ISU actuary donate. Also, if you go to smarturl.it /feed a starving actuary, you will find the same website. I know, there are no starving actuaries. It's just easy to remember that way. So here is the recent exam MLC, multiple choice section problem number 5. You are given that t, the time to first failure of an industrial robot, has a density f of t given by 0.1 for t between 0 and 2, 0.4 t to the -2 for t between 2 and 10, with f of t undetermined on 10 to plus infinity. Consider a supplemental warranty on this robot which pays $100,000 at the time t of its first failure if the failure is between times 2 and 10, so nothing if it fails during the first 2 years, with no benefits payable otherwise. You are also given that delta, the force of interest, is 5%. Calculate the 90th percentile of the present value of the future benefits under this warranty. A very important observation is that the warranty acts like a fully continuous term life insurance. The random present value of benefit, and we'll denote by z, is 100,000 times e to the minus 0.05t, but only for t between 2 and 10, and z is equal to 0 otherwise. We are looking for the 90th percentile of this random variable, so the value z 0.90 is such that the probability that z is less than 0.90 is 0.90. Let's note that the integral of the density f of t given over the range of values for which we have a formula for it is, well, the integral from 0 to 2 of 0.1 dt plus integral from 2 to 10 of 0.4 t to the -2 dt. Okay, the first one is the integral of a constant, so it's really 2 minus 0, 2 times 0.1, so 0.2. The second one, the function whose derivative is t to the -2, is t to the -2 plus 1 over -2 plus 1. And 0.4 is just a constant, and we evaluate that function from t equal to t to t equal to 10, with a value at 10 positive, and we're subtracting the value at 2. Well, it's not really positive because the -2 plus 1 is negative, so that makes it negative, but we're taking the value at 10 minus the value at 2. So we get what you see exactly there, 10 to the -1 over -1 minus 2 to the -1 over -1. So what we really have is 0.2 plus 0.4 times minus 1 over 10 plus 1/2, or write it with decimals, it becomes 0.2 plus 0.4 times -0.1 plus 0.5. So it's really 0.4 times 0.4 in that second expression, that's 0.16. The whole thing is 0.36, so there is going to have to be some other range where this density is positive, and of course it's only positive values that are possible for t, so it's going to be beyond 10. But the warranty doesn't pay anything after 10, so it's irrelevant for the in terms of what kind of density we have there, what kind of distribution. It doesn't matter, because all of those values of t beyond 10 translate into value of z being 0. And we just know the total probabilities of those. That's an important observation. So we actually know based on this that t is more than 10 with probability 1 minus 0.36 or 0.64. And we also know from the calculation that we did, we know that t is between 0 and 2 with probability 0.2 based on that first integral we evaluated. We evaluated two integrals. The first one corresponded to this range of values of t. So let's look at the possible values of z in order to find its 90th percentile. Well, z is 0 for t between 0 and 2, and for t more than 10. And the total probabilities of those add up to 0.64 plus 0.2 is 0.84. So z is 0 with probability 0.84. And this means that z is positive with probability 0.16, and this happens for t between 2 and 10. And then z is equal to 100,000 times e to the minus 0.05 t in that range, and that means that z is a decreasing function of t. So lower values of z occur for higher values of t, and higher values of z occur for lower values of t. And we see that from the integral calculation that we did is that the probability of t between 2 and 10 is 0.16. So to find the 90th percentile of z, we need to find the value t star such that the probability that t is between 2 and t star is 0.10, or equivalent to find t star such that the probability of t being between t star and 10 is 0.06. Because in the first range we have lower values of t, so higher values of z. So these are the highest values of z possible, and we picking the 10% higher values, and we're looking for a lower bound. And it corresponds to the higher bound t star. So t star, higher for t, the corresponding values, value for z will be the lower bound of the top 10%, which is the 90th percentile. And the same thing for the other one. Well, it's the low bound for t star, which means that it's the high bound, but it's already taken up 84% up to the positive values. You add 6%, you get 90th percentile. So we do the calculation. If 0.10 is the probability that t is between 2 and t star, then that's the integral from 2 to t star of 0.4 t to the negative 2 dt. And that turns out to be 0.4 times minus t star to the negative 1 plus 1/2. So that 0.10 is 0.4 times 1/2 minus 1 over t star, or 0.10 divided by 0.4 is 0.25. So 0.25 is 0.5 minus 1 over t star, so t star is 4. And then all we need to do is just find the corresponding value of z. So plug in for z equal to 100,000 minus times e to the minus 0.05 t star, and replace t star by 4, and the answer is 81,873.08, and that's answer A. Please remember this is copyrighted material, and problems from past Society of Actuaries examinations belong to the Society of Actuaries. Good luck with your studies, and good luck on the exam.